Alright guys, we're going to get into proving triangles. We talked about this fact yesterday on your video. Similar triangles have congruent angles, so this is important, and proportional sides. How do we know something is proportional? Hopefully you remember it has the same ratio, or cross product, or same multiple. Same cross product. Alright, I ran out of room. Sorry about that. Alright. So in here they showed that corresponding angles here, A is congruent to X. So if they didn't write this out, the congruency statement, you would have to see the marking. So I would have to see the same arc on A that I would see at X. I would have to see maybe two arcs at B. I would have to see those same two arcs on Y. And then let's go ahead and just make it a right angle, because it looks like a right triangle. And I don't know if you can see that on the C, but I made that a right triangle. Also remember that this little symbol here is our symbol for similar. Alright, and so there's going to be three ways we're going to prove similar triangles, and these are the three ways I'm going to ask you to practice at the end of this video. The first one, real simple. If I have two angles that are congruent, then I have angle-angle similarity. So as long as I see two angles that are equal to each other, then I can prove that the triangles are similar. And we'll get into how that is when I return. But if you look here, we know that angle A is congruent to angle X, and angle C is congruent to angle Z. So then I could write my similarity statement. Basically, I would say that the two triangles are similar. So I could say triangle BCA is similar to triangle YZX, by angle-angle similarity. And also, make sure you know the corresponding parts go together. If I start with B, that was the one I didn't have angled, I have to start with Y. And the reason why you can do angle-angle similarity is because we have a third angle theorem that says that if I know two angles are congruent to the other two angles of a triangle, then the third is also going to be congruent. So I only need two. All right, the other one is what we call side-side-side, SSS similarity. We just have to show, basically it says we're going to show that, let me just highlight this for y'all real quick. We're going to show that three pairs of sides are proportional, okay? And then I should have put out here, we show any two sides are congruent. All right, so I have to check the ratios of the corresponding sides and then see if they are the same or see if the cross products are the same. So my ratios, so basically on here, remember to show that they're proportional, we need to show same ratio or same cross product. So if I just line up corresponding sides, I have 10, this vertical side would correspond with, or BC corresponds with YZ. So I'm just going to write them up. 10 to 15 would correspond. If I go to my hypotenuse, that would be 12 and 18. And then my base would be 6. And I know I'm running out of room. I think you can make it fit. 6 and 9. If I reduce each one of these, 10 over 15, that would reduce to 2/3. 12 over 18 also reduces to 2/3. And 6 over 9 reduces to 2/3. Because they reduce to the same ratio, then I prove that all three sides are proportional. And now I can say that the triangles, I can make a conclusion here. So basically, I'm going to write it down here. I can say, therefore, triangle BAC is similar to triangle YXZ by side-side-side similarity. Okay? You can check the cross products as well. Oh, sorry about the bell. And then the last way to prove similarity is side-angle-side similarity, which is what we kind of use with triangles. Here we have to basically show that we have, let me highlight the key information with y'all. Here we go. We're going to show that we have two pairs of sides proportional, and the included angle is congruent. When I mean included angle, I mean the angle that is between the side, in between the sides. So if I look here, I have, we have the two sides that we have are the BC, which corresponds with YZ, which is what we did before. We have the 10 is to 15, And then we have to check both sides. So we also have to check the other side, which is CA, which is our base and 9. Well, we already did that earlier. We know that both of these reduce to 2/3. So we know that they're proportional. But then I have to check that the angle in between them, and I probably need to just kind of re-highlight this, but the angle in between them, the angle in between those two sides, it's C here and Y. And if you notice that angle C, okay, is congruent to angle Z. And C was the included angle. So now that I have a side, basically this is my sides, my two sides. We have a side, and we have the angle included in them that's congruent, then I can say that triangle BCA is similar to triangle YZX by side angle side similarity. All right, so these are the three ways we're going to prove triangles are similar. I need you to add the graphic organizer. You're going to paste this sheet into your spiral notebook onto your next available page. And then I have 3 examples that I want you to do. Example 1, I need you to draw these examples down into your spiral. Example 2, and get this bad boy to come off. Example 3. All right, so I want you to try to determine which similarity postulate you can use to prove that the triangles are similar, and write a similarity statement. Use prior knowledge, use known facts. I'm going to move this one a little bit. And you have a little hint for this one. You might need to redraw. I think this was on your other set of notes from yesterday. Redraw and separate the triangles. Sorry, I cannot write it. All right, so redraw and separate them, and then relabel them and see if you have corresponding sides, see if they share an angle. We talked about that on the last video. So I'm going to check to see if you come up with the answer. Thank you.